Hey there, class. Mrs. Matheson here. We're going to be doing notes 3.6 on triangle inequality theorem. Our learning targets is I can recognize and apply properties of inequalities to the relationship between angles and sides of a triangle, and then also identify possible triangles given the side lengths. So let's talk about that triangle inequality theorem. Triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So here we can say PQ plus QR must be greater than PR. So PQ and QR and then PR. All right, we can also say that about another set of two, QR plus PR must be greater than PQ. And last, we can say that about our third set, PR plus PQ is greater than QR. So we can say that if you see these three happen, that yes, it creates a triangle. So let's go ahead and look at these first three problems. So I'm going to take and add two sides and see that it's greater than the third. So 8 plus 15, is that greater than 17? So we're question mark, we won't know this. 8 plus 15 gives us 23. Is 23 greater than 17? Yep, it is. So let's try the next two. 8 plus 17, is that greater than 15? 8 plus 17 gives us 25. Is 25 greater than 15? Yes. And then is 15 plus 17 greater than 8? I sure hope so. 32 is greater than 8, so yes. So we can say, yep, this is a triangle. Now, we can ask ourselves that all three times, or we can think about it this way. I can add my two small sides and see as long as it's greater than my third side, my largest side, then yes, it's going to be a triangle. If that doesn't happen, it's not going to happen the other way. So let's just take a look back here at problem 1 before we move on to problem 2. 8 and 15 are my two small sides. As long as I add those two together and it's greater than 17, we know it's going to be a triangle because look here, 17, that one side alone, is already greater than the 15, and here both of these are greater than the 8. So we only need to do it with the two small sides. So let's see here, 6 plus 8, is that greater than 14? Well, 6 plus 8 is 14. Is 14 greater than 14? No, it's equal to. So we're going to say no, this is not a triangle. All right, I want you guys to try problem 3 on your own. Remember, we're only going to take the two small sides and add them together and see that it's greater than the third side, or my largest side. Okay, so let's look on to the next concept, is maybe we only are given two of the angles, or two of the sides, so we want to know what is the range for that third side. When we talk range, we're talking what's the smallest amount it can be and what's the greatest amount it can be. So we're going to take my two sides, 5 and 11, and we're going to set them greater than x. Well, 5 plus 11 gives me 16, so 16 has got to be greater than x, or we want to think x is less than 16. So that gives us our top part of the range. Now let's go ahead and add 5 plus x and set it greater than 11. So we're going to solve this by minusing 5. So we get x is greater than 6. Or we can think of this as 6 is less than x. So that's going to give us a lower part. Now let's go ahead and do our last two. And we're going to do 11 plus x is greater than 5. To get x alone, we're going to subtract that 11. So we get x is greater than negative 6. Now, x is greater than negative 6. Our side needs to be greater than any negative number. So that is not going to count. So really, we only need to do my two known sides greater than x, and then my small side plus my x. So let's try that with problem 5. My two known sides, I'm going to add those, set them greater than x. 3.8 plus 9.2 gives me 13. So 13 is greater than x. All right, or we can say x is less than 13. And then we're going to take my small side plus my x, so 3.8 plus x, and set that greater to my larger side. We're going to minus my 3.8 on both sides. And we end up with x is greater than 5.4. All right, so we have a range. 5.4 is less than x, and x is less than 13. So between 5.4 and 13 is got to be the range for that third side. All right, if we look here, number 6 is going to be a similar idea, but we're going to throw in expressions for all of these. So none of the sides are a specific number. So we don't know what our greatest side is, we don't know what our smallest side is, we can't base it just on the picture. So in a case like this, we're going to have to do out all 3 of those, adding and see if they're greater than. All right, so I'm going to take and add these 2 sides to start off. So x minus 7 plus 2x plus 12, and I need to set that greater than my third side of 4 times x minus 3. So I'm going to add like terms and get 3x and a negative 7 and 12. Notice they're on the same side of my inequality sign, so I'm just going to combine them. Negative 7 plus 12 gives me a 5. And set it greater than, here I've got to distribute. So we get 4x minus 12. I'm actually going to jot that down here just so we keep it like that. Okay, so now I need to move my terms so they're on the same side. So let's move our 3x over. So we get 5 is greater than x minus 12. Let's add 12 to both sides. So we're going to get 17 is greater than x, or we can think x is less than 17. All right, so that gives us part of our range. So that's good. Okay, now let's go ahead and add 2 other sides. And remember, I'm actually going to use that one. So 2x plus 12 plus my next side of 4x minus 12, and I need to set that greater than that side, x minus 7. All right, so I'm going to take my like terms and get 6x. 12 minus 12, oh, that's going to cancel. So x minus 7. So let's add x, or subtract x. So we get 5x is greater than negative 7. And then this should kind of bring a little red flag to you. We're going to divide by 5. What do we notice? We have a negative 7/5. Can we have a negative distance for a side? We can't. All right, so here's what I want you guys to do for me for tomorrow. Remember, this was 4x minus 12. I want you to take this side and add it to this side and see if it is greater than that side. Find me my missing part of my range. We have the top part. You need to find the bottom portion for me. Okay. All right. Then we have 8.4 Pythagorean theorem, and that says if triangle ABC is a right triangle with a right angle, C, then, you guys have seen this before, a squared plus b squared equals c squared. Now notice C is always opposite of our right angle. Always, always, always opposite. All right, so this should be familiar for you. So let's just set these up. Here's my right angle, so x is my C. And we're going to do a squared plus b squared. Does it matter if I have 6 squared plus 15 squared, or if I put it 15 squared plus 6 squared? It's not going to make a difference, okay? Here, again, my sides are my numbers, and my C is my x. Across from the 90-degree angle. Now this one's a little bit different. My x squared is a leg squared, actually. And my 11 is that C term. Go ahead, and I want you guys to solve these for us for class. You can go ahead and try number 10. Also, number 10 is just a word problem, and it's going to follow the same part. And so we'll pick up with 11 and be doing that in class. We'll see you guys then.